So, welcome to a review of straight lines. We're going to go through the parts involving graphing them and also deriving the equation using the well-known formula y equals mx plus b. Now, a graph is simply a plot of two values. Now, we learned them in math as x and y. X is on the horizontal axis, y is on the vertical axis. But of course, they represent and they can be called anything. An example here, we're looking at the minutes online as x and the internet pages viewed as y. And so here we have one point which matches 27 minutes online with 20 pages viewed. Now we can graph a multiple combination of values by taking many observations. Here, as you can be expected, or can be expected, the minutes online are related to the number of pages viewed, and there's some sort of a linear or linear-like relationship. Now we can find a line that is a best fit. Best fit, of course, is one where many points are on or near the line. Now, when we get deep into this, if you get into statistics, you know that can become quite a difficult proposition, but basically that's what they're doing. Now, once you have that, the line can be represented as a mathematical relationship, and therefore you're relating x, which in this case would be minutes online, with y, the internet pages viewed. Now, a larger data set could look like something like this. And there you see, as you can expect, there's that positive relationship. The more minutes you're online, the more pages you'd visit. And of course, based on the number of observations, you'll notice also that as the number of minutes grow, the variation in potential pages visits also changes. Now showing a trend line. That's how we'll that's how you establish a in this case it's a visual best fit. Now to come back to our smaller data set, we just take 2 points on the line, as we did here. Now, once we have these points, we can derive an equation for the line using those 2 points. Here we have those 2 points, again with the x and y values. One of them is 27 and 20, and the second one is 7 and 8 for the x and y values. Now we know, if you recall, the slope is the rise over the run. The rise means this vertical amount, which we can see here, and the run is the horizontal amount, which is there. So the rise is simply the difference between 20 and 8, and the run is the difference between 27 and 7. So there we have it. The rise would be then 12 over rise over run, 12 over 20, and that is equal to 0.6. Now we have the slope, which is 0.6. We calculate the intercept. We use the equation in the format we know, y equals mx plus b. Now we know m is the slope, so we have that value, is 0.6, which we just calculated. We can use either of these 2 points. I'm going to use a. So then we have the values for x and y, and then all we need is b. So putting in the numbers for point A, we have 8, which is y, is equal to 0.6. That's the m times x, which is 7 minutes, plus b. Rearranging, we have b equals 8 minus 0.6 times 7. That would be 8 minus 4.2, so b is equal to 3.8. We can double check this using the point B. Now point B, we have 27 and 20, so y is 20. 20 equals 0.6 times 27 plus b. Calculating that out, and moving it over, b equals 20 minus 0.6 times 27, and you can test it yourself. That's 16.2. So b again comes out to 3.8. So we have that value. Now we have the equation given the slope and the intercept. We just calculate it. We can write it in the regular format, which is y is 0.6. That's m times x plus b is 3.8. Translating that into what it means in our case, we have the number of internet pages viewed is 0.6 times the minutes online plus 3.8. Now, actually, this example is an indication that this is an estimate. Because if you took the values, for example, of 0 minutes online, then the value for y would be y equals 0.6 times 0, which would be 0, plus 3.8. Now, it's not realistic that we'll have 3.8 internet pages viewed with 0 minutes online. So in reality, it's probably a non-linear relationship, or there's something with the data there. It is, of course, as you can see, an estimate. So real life data analysis obviously doesn't always deal with exact numbers, but with estimates. But this is a pretty legitimate example in terms of how this works. So just keep that in mind, that there are always some underlying assumptions involved in any kind of statistical analysis. So there you go, and thank you for your attention. I hope that helped.